Hello YouTube. I have been learning how to build things with Godot, and I'll be getting into that in a moment. I followed the tutorial and came to a point where I realized that, yes, it's nice to have 6 balls bouncing around in a designed environment, but what if we had a few thousand? And to see the answer to that, I came over here to Godot and I added some code that instead of dropping 1 ball when I click the mouse, it drops, I think the current number is 20, something like that. Well, let's run it and take a look. You'll notice that there are some extra lines over here. What's that about? Well, that'll start to look like more of a thing as I click my mouse about 20 more times. There, 20. Notice that it's a line that has kind of that shape. It jumps up and then it decays down. Let's add some more of these balls to bounce around. And that shape is a shape that you will see in textbooks. In fact, if I go to Chrome and say kinetic energy distribution of a gas that I already had there, you'll see this picture from Khan Academy, so basically from the textbook. See how it goes up and then it goes back down again. And you can see that same, it's a little rough, but you can see that shape in the plot that I created overlaid on this quote-unquote game. I can show you if I jump into the code, this might be a little too much detail, but let's take the chance on it. If I go to main and the script, I have bins that go from 10 to 250 by steps of 10. And oh, this is interesting. Anyway, I have a dictionary of linear velocity to count, and I say if bin minus 20 less than equal to linear velocity and linear velocity less than bin, then this is a little bit of dead code down here, ignore the else, but if you can get the something at bin, which you can because I set it up above there, take that dict of linear velocity to count at position bin and add 1 to it. And the result of that looks like these data, where you have 20, 40. This was back when I had it split up by 20 instead of by 10. And the distribution of how many balls with that velocity you can see along here. Let's go back to the Godot engine, and you can see from this static image and from this one that's more jumpy, it's the same distribution. What's the lesson of all this? Well, I now know more about Godot than I did, and I'll have to thank Captain Fubar on Twitch for showing me through a lot of this. And the other thing is that I guess I can say that Godot has a legit physics engine that simulates the same kind of behavior that you see in textbooks. Also, did you notice that sometimes the little balls jump out of the water? I mean, I'm calling it water. It looks kind of like water, even though the physics is a little bit different. But that's how evaporation works, is random motion, and occasionally one of the molecules gets bumped really hard, and if it jumps out hard enough, it'll just float away. So I thought that was exciting the first time I saw that. Okay, enough for this YouTube video.